Okay, so we're going to talk about fossil fuel combustion and rusting. So fossil fuel combustion. So how many of the following things do we do each day? Switch on a light or use an electronic device, drive a car or maybe ride a bus, heat our home with a natural gas furnace, or use natural gas to heat the water for our shower. If we do any or all of these, we are relying on the combustion of fossil fuels, and in most cases, the energy stored in fossil fuels must be transformed into other forms of energy before it can be used. Combustion or burning is the most common way to transform this stored energy. So during a combustion reaction, a fossil fuel reacts with oxygen gas. The product of this combustion are carbon dioxide and water. Like all exothermic reactions, the combustion of fossil fuel gives off energy. In a car engine, some of the chemical energy released is transformed into kinetic energy to turn the wheels of the car. If you feel the car's hood after a long drive, you will know that most of the energy is given off as heat. So the following reaction describes the combustion of octane, which is a component of gasoline. So this is our octane liquid, is combined with oxygen to produce carbon dioxide, water, and energy. The energy being turned into heat, as also the energy for moving your car along. So, incomplete combustion. If a fossil fuel does not burn completely, then they undergo a chemical reaction called incomplete combustion. Incomplete combustion occurs if there is not enough oxygen available. For example, it may occur in a blocked chimney, or an inefficient furnace, or a car engine running in a closed garage. So, combustion produces three products: carbon dioxide, water vapor, and energy, where incomplete combustion produces five products: carbon monoxide, carbon dioxide, water vapor, and energy. Carbon monoxide, though, is an odorless, colorless gas that is extremely poisonous. It combines with blood in the bloodstream to starve the body of oxygen, causing death. The carbon produced in an incomplete combustion reaction causes the black coating soot that we see in our fireplaces. Now, the corrosion of iron. Corrosion refers to any process that chemically breaks down or degrades a metal. The best known case of corrosion is the rusting of iron. Most metals will rust, but the corrosion of iron and steel is a serious problem because these metals are widely used. As the rust flakes off of an iron structure, more metal is exposed to the environment, and this structure is weakened over time as more and more iron metal is exposed. So examine the chemical reaction of the corrosion of iron. So we have iron plus oxygen gives me iron 3 oxide, or rust. So as it says there, iron is reacting with oxygen to produce iron 3 oxide, which is commonly called rust. Although it is not included in this chemical equation, water is also required for rusting to occur. Now, solving the problem of corrosion. So have you ever noticed that the metal parts of a car that have been damaged in a collision are more prone to rusting? But why are some parts of a car rust while others remain rust-free? The answer is how the metals are protected. So painting is the first one. So one way to protect metal is to give it a protective coating of paint. Paint over metal prevents oxygen and water from reaching the surface of the metal, and this explains why steel beams used in office buildings or the bridges are often painted. Painting, however, may not be the best way to permanently protect iron or steel, since once the paint chips off, water and oxygen are free to attack the steel, and the rust blisters grow rapidly, as we can see here. So galvanizing. Another way to protect steel or iron is to use the process of galvanization. Galvanization is a process of applying a zinc coating on iron or steel, and this involves immersing the metal in a bath containing molten zinc. This process coats the metal with a layer of zinc that provides a protective barrier between the metal and the environment. The galvanized coating adheres to the base metal and resists chipping and cracking. In fact, the zinc coating actually becomes a part of the surface of the steel. Some galvanized nails also have a polymer coating to increase their protection. So sacrificial metal. A third method of protecting iron involves the use of a sacrificial metal. So if you look closely at an underground oil pipeline, you would notice bars or ingots of a second metal, such as magnesium, buried along with the pipeline. The magnesium will corrode, but the pipeline will not. In this case, the magnesium is sacrificed in order to protect the pipeline, since it is much easier and cheaper to replace the bars of magnesium than it is to repair a ruptured pipeline. So here in our our C drill here, we've got the legs, and then we've got magnesium blocks attached to the rig by cable. This magnesium, again, is our sacrificial metal. So even though this is not buried, I mean, it is submerged in water which contains oxygen, so that's what that's doing here. We also have sacrificial metals in our hot water heater. This prevents the iron tank from corroding, and we normally can see the top of the rod in the top of our hot water heater. All right, so thanks very much for paying attention, and we'll see you